hi there. Oh, you know what? Give me 1 second. We need to just lower one of my lights real fast. There we go. All right, friends. Hello. Happy Tuesday. I hope you're all having a good day. Oh no, our image is a little off today. Let's see. Maybe we just need to do a little. That hopefully will fix it up a bit. All right, hi there, friends. Happy Tuesday. Welcome back. I'm Miss Cassidy, and this is Miss Cassidy Creates. I'm going to go ahead and get our video going over here on my computer so I can see all of your wonderful questions and comments and all the nice things that you have to share with me. All right. I hope you're having a beautiful Tuesday. It's pretty sunshiny and gorgeous here, I gotta say. I'm excited for after we finish our video today because I think I'm going to go outside. I'm going to do some work in my yard and enjoy the sunshine. The sunshine will be so nice. Hello, friends. I see so many people. I promise as soon as I get my computer up, I'll see all the names and I can say it. Miss Cassidy can't see that well far away. So today, we are doing an oil and water science experiment. We're going to learn all about oil and water and how they act and why they act the way they do. All right, let's get the video up and rolling. All right. Almost there. Almost there. Let's see. I can see a little bit. Hello. Oh, hi, Janice. It's just you today. That's all right. And I think that says Rachel and Jacob. Hello. And Moira, I think. Let me see. I'm sorry, friends. I can't read it from that far away. As soon as it's up on my computer, we'll get it going. So today we're going to learn about water and oil. Water is the most important liquid on all of planet Earth. In fact, over 75% of our entire planet is made up of water in the forms of oceans, in the forms of lakes, in the forms of rivers. There's a lot of water. Did you know that you're made up of a lot of water too? You've got blood and bone and all of that other good stuff in your body too, but you are made up of a lot of water. And we don't just drink water, do we? Now, we do drink water because it's very good for you, but that's not the only thing we do with water. We can use it to clean. We can use it for cooking. We use it to irrigate or water our crops so that farmers who are making us growing us our delicious food can grow nice, healthy, strong, delicious crops for us. They help to clean the streets. If you've ever seen the street cleaner going down, they're pumping out water. They help put out fires from the fire hydrant. And we can even use flowing water to help power electricity. The stuff that keeps your lights on and your computer on and your TV on. Water helps make that run too. So I think it's no wonder water is such an important liquid, the most important liquid on planet Earth. All right, I think my video is finally working there. Sorry, our technology was moving slowly today. Oh, good. There are my friends. I saw Rachel, Jacob, Moira, hi, Peyton, and Kirsten. Hello, friends. Thanks so much for joining us. I'm sorry it took me a minute to get our computer go. So we are going to talk about water and oil today. Hello, Danae, I believe, or Deneen. That's right. I saw that. Oh, excuse me. Who's coming to say hi? This little buddy's coming to say hi. Hi, buddy. He's been desperate to get to the oil that we're going to play with today. So water is made up of tiny, tiny, tiny things called molecules. And molecules are made up of even tinier, tinier, tinier things called atoms. And when we make water, you have one big oxygen and two hydrogens. That's why when we refer to water, sometimes we refer to it as H2O, because we've got two of those hydrogens and one of those oxygens. And like we said, water does a whole lot of things and in a whole lot of different ways. Hi, baby boy. Thanks for saying hi to the cat, Janice. That makes me happy. It's sunny and cold in Maryland. I can't tell if it's cold out here. It probably is. It was cold yesterday, but it's so sunny. And hello, Amy. Thanks for joining us. So water does all of these amazing things, and it does it in 3 different states. We can have liquid, which is the version of water we're probably most familiar with, the stuff that runs through your bathtub and your shower and you drink. But then you also have a solid. Anybody know what the solid version of water would be? Solid means it's hard. Can anybody have any idea what might be a solid version of water? A certain very famous queen likes to shoot this out of her hands, if that helps. Ice, absolutely, good job. So ice is the solid version of water. Very good. Now, there's also another version because we have a solid in ice, a liquid in water, and then we have a gas. A gas can be steam or vapor. Have you ever seen when you open a tea kettle and all of that steam escapes? That's because we've heated up the water. The way we achieve these different states are by changing the temperature a lot of the time. So you freeze to get that solid ice, and all of those little atoms and molecules running around in there slow down. And that's why they freeze, because they're cold. So they stop moving quite as quickly. And as you heat them up, they start to go crazy and bolt all over the place. And that's why you get things like steam coming out of a teapot. Or I even have my steamer here, which we might turn on to take a look at the differences. So there's 3 different states of water. Hey, why are you standing on my stuff? That's because I put my stuff on his bed like a silly goose. Go ahead, buddy. You can take a nap while we do this. So, water is made up of 1 oxygen atom and 2 hydrogen atoms. Now, we're going to get into the interesting part about why oil and water act the way they do. Have you ever heard the phrase, those 2 things go together like oil and water? Maybe you've heard a grown-up say it. Maybe you've heard it from another science teacher too. So the reason we say that is because oil and water don't go together at all. It's not like peanut butter and jelly or mac and cheese or bread and butter. Oil and water don't want to go together at all. The reason they don't want to go together is because water, H2O, that wonderful little illustration we have there, H2O is polar. That means that it's charged with different negativities and positivities. Oil has no polarity to it. So on its own, it doesn't want to combine. That's why when you mix sugar with water or salt with water or even the food coloring we're going to use today with water, they both are polar. So that's why they're able to combine. However, oil is not. So oil repels the water. Do you know what repels means? Means it pushes it away. You can say, oh, you repel me, as in you make me want to go away. And the oil wants to go away from the water. Now, the other reason that oil separates, because when we see oil separate, a lot of the times it also rises to the top of the water. Maybe you've seen, if you're ever in the parking lot after the rain comes, if you see there's kind of a shiny surface on top of the puddles, it doesn't look like water. That's the oil from the cars. And that layer of oil likes to rise above because there is a different density to water and oil. Now, density is kind of a weird concept when you're first learning about it, because it sounds like it might be about weight, but it's not quite about weight. It's about mass and volume. So mass is kind of the heft. Excuse me, what do you think you're doing? Trying to get one of my cotton balls, I think. So density is about volume and mass. Something that is heavy and compact, like a brick. A brick would be something with a higher density because it is smaller and it is heavier. But something like a pillow, which is much bigger than a brick and much lighter, has a lower density. And the same thing is true of water and oil. Oil floats because it is less dense. It's more like the pillow. There we go. That's the word I was looking for. The other reason is because these are called immiscible liquids. Immiscible, like you can't miss them. Spelled a little differently, but to help you say it, think about like you can't miss. It is immiscible. Immiscible liquids, which means that they just don't like combining. So today we're going to play with our oil and water. For our first activity, we're going to go ahead and take a clear empty container. I've got a glass here. I'm also going to use my mason jar once it's empty to do a little bit of an experiment. But one container will be fine. However many different colors of food coloring you feel like using. And then I have a couple smaller containers to mix up my colored waters in. In school, you're learning about protons and neutrons and electrons. Moira, you're practically a scientist. You're learning about all of this stuff already. All right, so we have got our food coloring, some different containers, some more water. I've got a bunch of water up here. And then I got some light cooking oil. I've just got some canola oil, something that is light and able to be seen through. And then I have a little medical dropper that I'm going to use, but you can use a straw. You can use anything that you've got that'll let you pick up a little bit of liquid and drop it. So the first thing we're going to do is we are going to pour some oil. There we go. We're going to pour some oil into our clear cup. So be careful with this. Oil is very oily. If you know what I mean, that means it's kind of like it's viscous. It's a little thicker than water, which again kind of goes against the density thing. That's why density can be so counterintuitive. But you want to be careful while you're pouring that oil, because if you make a mess with oil, it can be a little bit of a pain in the butt to clean up, which we're going to talk about more later. So I've got my glass of oil. Now I'm going to go and I'm going to very carefully pour some of this water into my smaller containers. And like I said, you can do this with just one container and one color if that's all you've got. You can do as many as you feel like. Totally up to you and whatever you've got laying around. So I've got my little jars of water, and now I'm going to go ahead and add some color to those. So you don't need a ton of food coloring in these. I'm going to just put like 2 or 3 drops in each. Right into my water. Ooh, it's so fun to watch. Let me see. I'm going to come over and do one over there so maybe you get a close-up look of watching that food coloring kind of dissipate through. All right, ready? Let's see. Pretty cool, huh, to watch that. All right, one last one. Let's see, we did the green. Oh, I need my yellow. That's the one I need left. All right, 1, 2, 3, done. All right, and I forgot to bring a spoon up. Oh, but I do have a popsicle stick, which will work. Take a spoon or a popsicle stick and just give it a nice stir so that your colors get all mixed in with the water. There we go. Some beautiful multicolored water we've got going on up here. And now I'm going to scoot you a little closer so that you can really see our science at work here. So let's scoot you in and let's see, can I... Ooh. Sorry about that, friends. Pressed the wrong button, as sometimes happens. All right. Hopefully that's going to be a decent angle for you to see. Hi there. Oh, we're so close now. Hi there. All right. So here's our oil, which, let me see. We're going to try one more little bit. All right, that's okay. I'll just hold it up and you can be nice and close that way. All right. So we've got our oil. Then I'm going to take my dropper and I'm going to reach into one of my fancy colored waters. And then we're going to drop it in and we're going to see what happens. What do you think's going to happen? We talked about the density difference of oil and water. We talked about how it's made up of different things. But what do you think's going to actually happen when we drop this oil in there? I guess we're going to have to see, huh? All right, let's take a look. Ready? Can you see those? Here, let's see. I'm going to pick up my phone. That's going to be the better way to do this. The fancy camera work of Miss Cassidy. There we go. So check that out. We see the oil lands on top, and then it is starting to go down a little bit. Oh, there we go. Drop some more in, some green this time. And you see they start to drop. But the ones on the bottom, they're not combining. The other oils are staying separate too. It doesn't matter that they are all oil in there. Or excuse me, the water droplets don't want to combine because they can't make it through the oil to join together. Check that out. That's pretty cool, right? Let's see, we haven't put any orange in there yet. Let's do a little orange. So look at that. You've still got some floating on top, but a lot have gone down to the bottom. Now that might be due to the fact that when it's combined, remember we talked about oil is on top. So that oil is trying to push the water down, and maybe those smaller droplets on top, like you see those little blue guys right there, since they're smaller, they might not have, how do I turn around? There we go. They might not have enough density to sink down below, even though they're water and they are more dense than the oil. Because they're smaller, they probably are resting on that top a little bit more, and those big guys are hanging out at the bottom. Now I'm going to do another part of this where you can do this along with me if you want, or you can just watch what happens. I'm going to take my mason jar and I'm going to pour my oil and water in there, and see, even now my water is still staying totally separate. I didn't want to use the mason jar the whole time because I find that it's a little hard to see through all of the glass work on it. But we're going to switch it to this one because I'm going to close it in a second. We're going to add a bunch more color. We're going to go crazy. We're going to add a ton. We're just going to squirt it right in. Nice big bubbles. All sorts of colors. I love science, guys. It was one of those things that I wasn't very good at it when I was in school, but I was always so interested. And this stuff is just so neat. Like, Moira, I'm so glad you're learning about all of this stuff in school, because it really is super interesting. Even if you don't want to become a scientist, or even if you only want it as a hobby, you can like all sorts of different things. You don't have to just like science, or just like English, or just like history. You can like all sorts of stuff. And you can even like stuff that you're not always great at, and that's okay. So we've got this awesome jar full of all of those watery, even because I poured in so much so fast of the blue, we can see it's kind of expanded down there. But even with that, you can see they're all still separate under there. What do you think is going to happen if I shake this jar up? If I shake it super hard, do you think that oil and water is going to relent, and then they're going to go, fine, Miss Cassidy, we'll go together if you insist? Or do you think it's going to stay strong and it's going to stay separate? What do you think is going to happen? Let's give it a shake and find out. Shake it! Shake it, shake, 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 shake. All right. Well, if you look closely, you can still see little fragments of that water in there, but it's kind of all combined into this green color. Very interesting. Do you think it's going to stay this green color? I don't know. We're going to put it aside and we're going to check in a little bit and see, because I honestly don't know. This was part of the experiment I didn't do ahead of time because I wanted to learn about it with you guys. So we're going to put that off to the side and give it just a couple of minutes till we can see what reaction happens. We're going to do another little experiment here, and this one is going to be about our oceans. Now, we talked about how the globe, our planet Earth, is covered in 75% water, and obviously a big part of that are our oceans and our rivers and our lakes. However, we use all of those things not just as water sources. We travel across that water. We have big boats. We have planes that fly over them. We have all of these important pieces of machinery that carry us goods. They bring us food and clothing and all sorts of stuff across these massive oceans. And unfortunately, sometimes, as it happens in life, things might go a little wrong. So when things like that happen, when we have an accident, like a boat might crash that's carrying oil or is being run by oil, because a lot of these boats are, or a piece of equipment breaks down so that it makes it so that it's leaking, or even a natural disaster like an earthquake or a hurricane. Sometimes that can cause what we call an oil spill out in the ocean or a lake or any body of water. You can in fact have an oil spill on land as well. But we're talking about, hey, you give me back my cotton balls. He's trying to steal my cotton balls. But we are going to talk about an oil spill in the water. So like I said, there's a lot of different ways that an oil spill can come about. But as you can imagine, that must be tough to clean. We've talked about that oil has that kind of greasy feel to it. And when it separates from water that way, I don't know if that would make it easier or harder. What do you think? Well, what we're going to do is we're going to make our own little ocean next. And then we're going to make our own little contained oil spill. And we're going to see how easy or how hard it is to actually clean that up. And this is why I wore my whales headband today, my favorite headband, because whales are some of my favorite animals. Because I love the ocean. And these little guys, when they get stuck out there, that can be a problem during these oil spills. So, let's see, we're going to take you... Fold it down a bit, and you know what? I think if I make my lit thing higher. Technical difficulties. Hold tight. Can you see baby boy down there? There we go. Ooh, smacking things now. All right. So... Can you? No, that didn't even do it. How about there? All right, we're almost there. That'll work. All right, so I've got my big empty pie plate. I picked a clear glass plate so that we can really see all of the different layers here. Now we're going to take our water. You're going to go ahead and you're going to pour your water very carefully into your pie plate. And then for a little extra fun, we're going to go ahead and I'm going to pour in this blue water that we had used so that it really feels like it's the ocean or it's a big body of water. So there we go. We've got our ocean going on. Now we're going to take our oil. We're going to pour just a little bit in. And then we're going to pour a little bit more as we go. Start small. Now, can you see? We're just gonna grab it. So look at those big globs of oil on top there. See how it's just rising to the top of that water? Here, we'll even pour a little bit more in so you can see it create. Now, how do you think we're gonna clean this up? What could you use? Well, I've got some cotton balls here. Maybe cotton balls would work? Let's see. Well, the cotton balls are definitely picking up some of the water when I go underneath because we can see the blue coming. And I think it's picking up a little bit of the oil because I can feel that greasy, greasy oil. But there's still an awful lot in there. Let's try another one. What do you think? Yeah, we got some of it up, but it's really not doing, there's still a whole lot in our little mini ocean there, isn't there? Let's see, what about, I've got Q-tips. Let's try a Q-tip. Oh, you see what that did? That didn't really pick any of it up. In fact, it just kind of spread it out. Spread it out a bit. All right, well, maybe not on the Q-tips. What about, we're going to try feathers. Because you got to think about, what are some of the creatures that are going to be affected by something like this? You've got your birds that like to land on the surface, and when oil is sitting on the surface of the water, then that means that the birds are going to get it right on them. Maybe it'll be okay for their feathers. I don't know. We'll see. So I've got my feathers here. The other thing you got to think about is mammals that use the surface of the water, either if they're underwater creatures that still breathe like mammals, so they have to come up to the surface to breathe, and then they get stuck because that oil's sitting on top, and that goes right into, if they're a whale, it can go right into their blowhole. Or if you're a mammal that lives on land but relies on using the ocean to go to get your food, like a polar bear or something like that, they can get stuck. So let's see what happens to our feathers. Maybe that'll do something else. So we've got our feather here. Oh no. The feather isn't even picking up any of the blue, but look at how those feathers just get totally stuck together. That dry part is nice and spread out, but down where there's the oil, it's totally stuck together. That's not going to be super helpful when it comes to flying, huh? That's probably going to make it pretty hard for a bird to fly. So that's tricky. You can try some other things at home too. Maybe you have a spoon. Maybe you have anything you feel like trying. Do a couple different things. Have your own science experiment and see what helps clean up the oil out of your water, and also see how not easy it is to clean up that oil from that water, because that's really difficult. If you've ever seen information about when there's an oil spill, a lot of times there are a large number of helpers who have to go out, and they either use a chemical that helps break up the oil. So think about like if you're helping your parents do dishes and you use Dawn dish soap to break up the grease, kind of a similar thing. The problem is that you're adding more chemicals into the water that has already had a hard time because of the oil. So that might not be ideal. And when you think about how the water from the ocean gets to all of us, do we want those chemicals coming into our bodies or into the food we're going to eat? Anything like that. So chemicals are a way that you can do it, but that can be difficult. That's not always preferred. You can also use, if the waters are calm and still, like how if we see on ours, we don't have any waves going on. So we've just got a nice big blob of oil right there. But if we make waves, it's going to be a lot harder to skim that oil off the top now, isn't it? Now think about a crazy ocean with big waves, especially if this comes out of something like a hurricane where we have high winds. That can make it really hard to deal with. The other way that we can clean up oil spills are there are special machines that are used that help to separate the oil and the water. But it's really hard work. It's really difficult, which is why we have to work so hard to protect the water that we have and to be responsible as humans in charge of this planet to help take care of it. Make sure that when we spill these chemicals and these things that we need, we also make sure that we're taking care of the animals and the rest of us that are going to feel it eventually. Even if we don't feel it in our feathers, the same way the pelicans might, we're going to notice eventually. So one of the things that you can help do is to help be aware of the oil products that you use. Be careful about, obviously the cooking oil that we use, that stuff's pretty healthy. There's a lot of different kinds of oils. You can also do your part to research all of the different animals and to just become the best, smartest scientist version of yourself. So that even if you aren't able to directly help with the cleanup, because as we learned, that's hard, you can still be supportive by being aware of all of these things and teaching others, because that's a great way to share your knowledge, is to teach other people and show them what you've learned. So let's check in with our jar here that we shook up. So that bottom, I'm starting to see that separation happen. It looks like what happened is our water droplets that hadn't been combining when we dropped them right in, once we shook them up, all of those colors combined. That's why we have this cool, funky green color happening in there now. And we can see slowly but surely it's starting to separate. The longer we leave this jar alone, the more we'll see that separation. We'll probably never get the colors back that we used, but we'll start to see a distinct line of oil and water and where one begins and one ends. So let's see. That, friends, is our lesson about oil and water. I hope you had a good time. Oh, let me get my, are you on? There we go. Wow. I hope you had a good time learning about oil and water. I know I sure did. I love science. I love learning new things. I hope you got to learn something new today. I know I did. Tomorrow we're going to have a kitchen adventure. I'm going to post the ingredients for that in just a couple of hours here. We're making leprechaun bait. There's a nice overview on the weekly schedule, which will be pinned to the top of the page. Miss Cassidy is not speaking very clearly today. We have an overview of the ingredients up there now if you need to go take a look. And like I said, I'll put a more detailed post up later today. That's going to be at 3 o'clock tomorrow in our kitchens making some delicious snacks. And otherwise, I will see you all soon. Thanks so much for joining me. You keep on being yourself, keep on smiling, and I'll see you soon. Bye!